Thank you. Hello, everyone. Welcome to my talk today. I'm going to be talking about the applications of Dupont Liveo silicone adhesives. So why silicones? Why do they excel in healthcare? You can see in the different areas that DuPont sells in healthcare, from tubing and elastomers to adhesives, excipients, and then also we talk about silicones in general and why they are good for healthcare. For things like adhesives, we can have long-term adhesion. They promote easy and comfortable removal, and they are non-irritating and non-sensitizing. So silicone adhesives for the medical device area is what we will focus on. So why is this important in the medical device industry, and what are the trends? So with our growing and aging population, there's more and more demands for medical devices and for gentle adhesion to the skin, for the fragile skin of the elderly or even for newborns. It can help improve quality of life, to help with pain management, and increases convenience. So people aren't staying in the hospital so long and go home and can still be monitored. And also, the improves compliance and safety, so different new products that can deliver different types of medicine or be able to monitor different things such as heart rate or heart monitoring devices. So we have a range of silicone adhesives in our portfolio. First, we have our soft skin adhesives, or SSA. These are used typically on fragile skin. They're atraumatic upon removal, so they don't hurt your skin or tear your skin, and also for advanced wound care or for scar care. And I will get into each of these more when I talk about the specific adhesives. We also have our pressure-sensitive adhesives, PSAs. These are used more on healthy skin. They secure some type of device to your body, and they can be used in things such as ileostomy, external prosthetics. Sometimes they're actually used in the theater industry. And you can see both of these can be used for wearable devices. And from left to right, the SSAs have more of a gentle adhesion, whereas the PSAs on the right side have a stronger adhesion. So when we talk about our soft skin adhesives, these are basically a low consistency silicone elastomer. It's unfilled. They are more of a soft gel type material, and they are 100% silicone, so there's no solvent in these. The benefits, if you have a bandage or some sort of patch, they have a very soft touch. It's flexible, transparent. They are very comfortable to wear. They, again, are one of the benefits of silicone is they're non-sensitizing, non-irritating, so people don't get rashes or develop a sensitivity to the silicones like some people do to other materials like acrylics, which are typical for adhesives in the healthcare market. And with soft skin adhesives, one of their other benefits are that they can be repositioned. So once you put it down and adhere it to you, if you need to lift it or move it over, that's possible. Such as when you're in the hospital and you may have some sort of surgery and the doctors and nurses want to continually check the wound, they remove the bandage and then they put it back on, and it sticks just as well as the first time it was applied. Again, some of the adhesions or the applications are wound dressings and This is, again, due to when they pull it up, it doesn't hurt or damage the skin. So if you think of, it's very different than, let's say, like a normal bandage that you put on and it has some good adherence. It's a little different than that. And we'll get to the samples that I passed out that you can look at. Another big area they're used in is scar management. So they will put it on a scar that you have, and the silicone helps with healing of that scar, so there's less likely of you to have a scar that remains once your wound has healed. And also, again, device attachment, and this is getting even larger with all of the monitoring devices that are out there these days. So a little bit of the basic chemistry for a soft skin adhesive. It has two different parts. It's a part A and a part B. Again, it's 100% silicone. And the part A is basically a polymer with a platinum catalyst to induce the chemical reaction. And then part B is base polymer with cross-linker. So you mix these two parts together in equal ratios and it begins to cure. And it's a very lightly cross-linked material. So also, when you make the materials, it's heat accelerated, and we'll get into that a little more. And also, there can be some risks with potential cure inhibitors because of the platinum reaction. So excessive moisture, that if that gets into your system, that could cause slowing the cure rate, as well as some sort of platinum inhibiting substances such as heavy metals or sulfur compounds. So this shows during our processing, usually in a development like I do, or in some sort of laboratory, we mix those two bottles of material at a 1-to-1 ratio, and then we put it in like a vacuum oven to remove the air so there's no bubbles, and then you use a drawdown bar to put it onto a substrate, and then cure it in an oven at usually 130 C is what we recommend. In a pilot and production process, you'd still do the 1-to-1 mixing, but you would have pumps that pump that in so you have continuous feed. Usually it's a knife over roll for coating, and again, you cure at 130 C. And for these particular adhesives, the sterilization method that's preferred is ethylene oxide. Some of these other ones that are higher energy will cause the material to cross-link more, and it becomes very stiff and loses its adhesion. You can see in the plot as you go across, this is basically showing the cure rates and how long it takes them to fully cure at different temperatures. So it goes from 130, we have 100, 80, and then 60 C. You could leave these sitting on the benchtop at room temperature and they would cure, but your properties would be slightly different than the recommended 130 C. So your laminate for your construction, your soft skin adhesive has to be coated directly onto your final substrate, and there are a variety that you could use them on: polyurethane, another silicone, a type of plastic film, foams, things like that. There is a potential that depending on the material you coat it on for your backing, you may need some sort of adhesion promoter. Usually some sort of tightenate is used, or you can use some gamma treatment or corona treatment. It just doesn't work quite as well as what the actual liquid adhesion promoter does. And for a release liner, the good news is it's very cost effective. You can use something like polyethylene or polypropylene, so it's very cost effective. And then also for your coat weights, we recommend that you have, for good adhesion and make sure there's good cohesive properties and so it doesn't come apart, usually somewhere between 150 or 300 GSM, or usually it's like 6 to 12 mil is what that equates to. So this is basically just a diagram of what a continuous process would look. You can see on the left side, you'd start with your backing substrate coming across. You would have your part A in one drum, your part B in the other. They would be metered into a static mixer, so it doesn't need a lot of shear. It just needs to be mixed thoroughly. It is then dropped onto your substrate, go under a knife to the thickness. You then put it through your oven, and then as it goes through, you then put your release liner on the right-hand side and collect it as a roll. There we go. These are a list of our different silicone adhesives, or our soft skin adhesives. Several of you, I passed out one of them on the product. The first one on the far left is MG79800. So the soft skin adhesives, you can open up that little container, and if you didn't get one, you can come up later if you'd like to see it. If you just press your thumb into it and then pull it out, you can see that it has good adhesion. It doesn't hurt when you take it off, as well as you can feel on your skin that there's no silicone residue left on your skin with that. So we currently have 4 different products of our soft skin adhesives, and they range in viscosities, but the big thing is the penetration, which measures the softness or hardness of the material. So as you move to the right, you can see the materials become softer, but it also, with that increase in softness, the other property that increases is the adhesion. So you'll get a stronger adhesion as you move across in the product line. So now we're going to move on to the pressure-sensitive adhesives. So the pressure-sensitive adhesives, these are a one-part system. So it's a polycondensed polydimethylsiloxane with a polymer resin or silicate resin. So it becomes a very strong adhesive network. These materials are sold usually in a solvent, and typically the solvent that we use in most cases is ethyl acetate, which is common in healthcare. And we also have some other solvents and solids content that we do offer, but this is what is typical for our pressure-sensitive adhesives. The benefits with these, again, they're non-sensitizing, non-cytotoxic. They have good breathability, good moisture transmission rates, and has a bit higher adhesion and longer wear time. The applications for the PSAs would be monitoring devices, ostomy, external prosthetics again, or some sort of surgical dressings. And by surgical dressings, I mean the ones that are, so not your one, like for example with a shoulder surgery that I had, there was bandages on each of the wounds, but then they have a big bandage that's on top of it all, and that would be with PSA because it's much more difficult to remove. So again, these are made up of 2 different components that are reacted together, a polymer and a resin. And they're processed when we make them in xylene. And then with the catalyst and then a capping agent, depending on the adhesive. And then once we're done, we'll put it in a final solvent. We also have the similar ones, which I'll talk at the end, that are in our PSA line, but they are specifically for drug delivery applications, not for medical device adhesion. So with the processing of the PSAs, one of the advantages to these are you actually coat it onto your release liner that you're going to use, and then you can transfer coat it onto any type of substrate that it will adhere to. So if you have more of a lighter weave material, something like that, it can be transfer coated onto that material, so you don't have to cure it right on it like an SSA. With these, again, the adhesive itself is already made during the reaction process. So really, this one, you're not doing any type of reaction. It is just you are drying off the solvent in order to leave the remaining adhesive. We also have, that's the solvent-based ones. We also in this line have ones that are a hot melt adhesive. So these are, if you look at it, you would think it's really a solid, but technically it is a liquid. It does flow. It'll fit to its container. It may take a little while, but they will. And those are, once you heat it up to about 180 C, and then once you collect it, you basically cool it down, and that's what leaves your adhesive. And then again, like I said, you can then transfer it to whatever final substrate you want to use it on. Some folks, especially I talked about external prosthetics or in the theater, some people will use it for where you're basically brushing on the adhesive. So they will, let's say for theater, they have external nose prosthetic, and they will brush the adhesive onto that, allow it to dry so the adhesive is left, and then apply it onto the person's face. And I have to point this way. So again, here is the processing steps for a PSA. You can see it's very like the SSA process. The only difference is you only have one vat of material, and that feeds directly onto the line and then is coated to the proper thickness that you need. And with these, the one thing with these solvent PSAs, they do require right now a fluorinated release liner. We're looking into different ones with all of the things out there regarding PFAS. So some of these are not being made anymore, so we are looking at different ones. But it is a bit more expensive than polyethylene or polypropylene like with the SSAs. So here's the product line that we have for our SSAs. If you look and you have the sample cups, there's one that says MG2402. If you open that one and touch it and you put your thumb on it, you'll notice if you touch it very lightly, you'll realize it doesn't feel very tacky at all. So it doesn't have a lot of tack to it. However, if you push your thumb into it for a minute, hold it there, and then pull it off, you will definitely feel the higher adhesion in that material. But again, when you pull it off, you don't have any silicone residue, anything like that. But you are going to feel it more than you would an SSA, which is used on more fragile skin. And on the far right, that one, the 2410, that's our hot melt adhesive. That one is very tacky, very high tackiness. And the MG2401, that one has the hexamethyl disiloxane solvent. So that one is used more in making, formulating for things such as a spray adhesive, where the MG2402 and 2502 are used more in the coating process lines. So if you look at this slide, this is showing our full range of products tested for adhesion. On the left side is the blue, and those are all our soft skin adhesives. And to the right, in the purple, is our pressure-sensitive adhesives. We also show that because typically in industry, a lot of the testing is done against stainless steel. And the stainless steel ones are the lines with the stripes through it. That was done against stainless steel. So on the right, you can see our PSA line. We get very good results against stainless steel, which is very common in industry and is used there. On the left side with the SSAs, you can see when you're looking at these striped lines, we don't see much difference in these different adhesives. So we actually had to come up with a new test that we test against polycarbonate, and that gives us a better way to be able to distinguish between the different materials. And you can also see at the bottom on the left, the SSAs are coated at a heavier coat weight, so thicker, so about 250 micron compared to a PSA, which is typically 25 to 50 micron. We also do internally in our group, we will do wear studies on the materials. So we will formulate, we will make patches, and we will have folks within our group wear the patches and look at them, evaluate them every day, see how they're wearing. You know, are the edges rolling off? Do they completely fall off? It gives us a good range of skin types because everyone's skin's different. So you know, some people, they'll fall off within a day. Other people, they will last forever. So it really depends on people's skin types. With these, if we compared our soft skin adhesive at the time, our highest adhesion one, as well as to the 2402 PSA. And you can see, to explain this chart, at greater than 3 days, 77% of the MG7 9900 were still being worn, at least 75% were still adhered to the body, whereas with the PSA, it's all of them, 100% were still adhering. So you can see that with the PSA, we got up to about 10 days and still 96% of them were still adhered to the skin. Whereas with an SSA that doesn't have that higher adhesion, it was right around 50%. So the PSAs do have a higher adhesion. And at 14 days, we're about 78% of the people still were wearing them, which is pretty good. And a lot of that has to do with everyone wants much longer adhesion time and wear time. The problem is, they'll ask for 21 days, 28 days. The problem is your skin is always regenerating. So as that regenerates, it also affects how much something will adhere to it. So the longer time it is, more of your skin is regenerated, so the patch is not adhering as well to your skin. So this just gives a summary of the SSAs versus the PSAs, so you can see a bit of the comparison side by side. Again, the SSAs are a two-part system, but there's no solvent. You have heat curing, and then you usually have to use a primer. And there's the Reese liner is, a pretty cheap release liner, and the coat weight is a little heavier, about 6 to 12 mils. And then with the PSAs, again, there's two different ones. They're both one-part materials. One's a solid, one's in solution. So the solution ones, again, are solvent-based. You just dry the material to end up with your adhesive left. And you do need a floral liner, so that adds a little bit of expense to it. But also then it's usually coated thinner at only 2 to 6 mil. This is the same basically with the one-part solid. The hot melt, you just have to heat the material up and then allow it to cool, and then your adhesive is left. So just to give a little bit of a very basic of our bio PSAs, because I know some people have asked about these. With our bio PSAs, we have a tack range, and it's very subjective. So, high, medium, low. But it's very easy to tell the difference. We have some that are amine compatible. We have standard with silanol, reduced silanol content, as well as just our standard PSAs for these. You can see on the left there with the solvents, we have a much more larger variety of solvents that we do for these. And also with these, the one thing is that typically people are using these to deliver some sort of drug, do some transdermal drug delivery. We tend to work with companies very closely with these because the type of drug that they want to put into the patch needs to have a specific type of functionality or properties with the PSA. So we do work very closely with companies to help them develop stuff like this. And in all of our materials, you can see them at the Química San Diego booth here. They are our exclusive distributor here in Mexico. So, they've had people ask about these, and again, it's something with the bio PSAs that we usually tend to work close with companies so that they're getting the best, and we can recommend what type would work best with the type of drug that they have. So adhesive requirements for the transdermal, again, similar to our others, they usually want adhesion to skin for 1 to 7 days. So not only do you have to have good adhesion with the adhesive, you also have to make sure that there's good adhesion once you add your drug into the matrix. You have to have good cohesive strength, minimal cold flow. So when you have a patch on, or let's say a Band-Aid, which people are more familiar with, and you get that black ring around the bandage, that's cold flow. So the adhesive is moving out from the bandage. And also, obviously, you want them to be moisture resistant so people can still shower, things like that. And when we do all of our wear testing, we actually let folks live their life as they do a normal day. So if they were showering 2 times a day, they could still do that. If they exercise heavily, they still do that, because we wanted to make sure all of our wear studies were indicative of how someone would live their normal life. And again, for the pharmaceutical capabilities, we want to make sure that the adhesive is inert towards the drug, that there's acceptable release rate from the attach to through the skin for the person. We do a lot of studies within our lab, making sure certain drugs will release correctly in our new adhesives, and also compatibility of the adhesive and the excipient, so it actually will let go basically of the drug and let it go into your skin. So that is all I have. If anyone has any questions, I'll take them in a moment.